Hello and welcome to another ZoneScan Net mini tutorial. I'm Max Ward, your Customer Success Associate. These are a series of videos we're doing in order to get customers to start thinking of ZoneScan Net more like a tool and less like just another way to view their data. And mastering this tool really does make a huge difference when it comes to the accuracy of your data and getting to know your system. And it can save you hundreds of man hours potentially, and of course headaches down the road. So in this video, I'm finally going to go over without pipe correlations, otherwise known as double-headed arrows. These are some of the most common things on ZoneScan Net. They're some of the most frustrating, and there is a very easy, quick checklist to go through to try to get rid of them. So I'm going to go through that, and then I'm going to go through each of the fixes that you can employ each step of the way along the checklist. So first, a definition of what double-headed arrows mean. Double-headed arrows are ZoneScan Net's way of telling you that it doesn't have enough information to give you a pinpointed location for that correlation. So it has enough information to correlate, but it doesn't have enough information to tell you where that leak is potentially along that pipe. So here's a quick checklist to go through to find the culprit, to find the reason that this double-headed arrow is appearing. So first, either manually drawn pipe or GIS data is not present. So if there's no pipe, then the loggers can't be connected to that pipe, and ZoneScan.net can't tell you where that leak is, which leads us to our next culprit. Loggers are not assigned to a pipe node. So you want to always make sure that your loggers are, first, that they're where they're supposed to be, and second, that they're assigned to a node that is closest to them. So third, if there is pipe data and the loggers are assigned to it, then it could be that there's an error with the pipe data itself. It could be that there are pipe junctions that are not connected, or the straight length of pipe has a very small gap hidden in it. So lastly, if you checked all the previous culprits, ZoneScan Net has a correlation limit that is defaulted to a certain distance. And if the loggers are further than that distance apart, then you're going to see a double-headed arrow instead of a spot. So now a brief overview of the fixes for each of those steps along your checklist. First, if there's no manually drawn pipe or there's no GIS data, then you're going to have to manually draw pipe, and I'm going to go through a quick tutorial about how to do that. Second, if the loggers are not assigned to a pipe node, I'm going to show you how to assign them to pipe nodes. So third, if there's a problem with pipe data, I'm going to show you a quick as-you-go sort of approach to close tiny gaps in your pipe data, as well as connect those disconnected pipe junctions. There is a feature that we can go through here at Gutermann to help you fix some of your GIS data, and we can set that up for you. It's a very quick process, but it is something that we have to do on our end. In this example, right away, you can see that there is no pipe data present. There's no manually drawn pipe, there's no GIS data. So as a result, the correlation you're seeing is a double-headed arrow. So the fix is either uploading all of your GIS data or manually drawing pipe. So if you're manually drawing pipe, only draw the pipe between the two loggers that are giving you a correlation or giving you a useful bit of information. Don't draw pipe data all over the place. Just do it as needed. So manually drawing pipe is very simple. There's just a handful of steps to go through. First is locate one of your loggers and right-click nearby. You're going to see a window pop up and choose Create Pipe. Now you're going to see two white dots on either end of this pipe. These are what's called pipe nodes. And there's going to be a transparent dot automatically in the middle of those two pipe nodes. That is a potential node that you can click and drag to create a brand new pipe node, and as you'll see, there are two more transparent nodes now that have appeared. If you want to delete the pipe node, just right-click and choose Delete Node. So right away, before we worry about pipe material or pipe diameter, let's click and drag this pipe node over to the next logger, wherever that may be. Then you'll see a pop-up window asking you if you want to connect the pipe to the indicated logger. So hit yes. And as you can see, drawing pipe now gave us that red spot that we want to see. Even if there are a multitude of bends along this stretch of pipe, you always want to start by inputting the pipe material and the pipe diameter. And I'll show you why in a minute. So let's input the pipe data for this example. Right-click on the pipe choose change pipe segment material. In this case, let's change it to cast iron. And let's change the diameter to 8-inch. So now that we have our pipe material and our pipe diameter selected, we are free to right-click, choose Edit Pipe, and create any sort of bends we want to create. And that pipe material and diameter is now present in each segment. If you want to change this now after you've made all these bends in the pipe, go down to the first logger, right-click on the pipe next to it, choose Select Pipe Segment, and then go all the way to the next logger, right-click and choose Extend Selection to Pipe Segment. This will highlight the entire stretch of pipe between your two loggers, no matter how many bends you have put inside of it. So that's basically it for drawing pipe. And you can really make this pipe as detailed as you want. You can add as many nodes, as many twists and turns as you'd like. So let's move on to our next example. Now in this example you can see that there is GIS data present, so we can check that off the list. And next let's check to see if each of these loggers are assigned to a pipe node. So as you can see, this northernmost logger here has a red line extending from it to a spot on the pipe. That is indicating that that logger is connected to that spot. ZONESCAN thinks that this logger is right here. Now if we go down to the southernmost logger, we can see that there is no red line stemming from it. So let's right click on this and go down, and you can see that the detach from pipe node option is grayed out. That's because the logger is not attached to anything at the moment. So let's choose assign to pipe node. And luckily a pipe node popped up right next to it, so let's just click on that. And now that that logger is assigned to that node, the double-headed arrow's gone away, we have our pinpointed spot. So let's say that there wasn't a node right next to this logger. This kind of ties into the previous step of creating pipe. And you can create additional nodes on GIS data as well in the exact same way. So let's just delete that node, right-click on the pipe, choose Edit Pipe, then locate that transparent node, click and drag it. And now when you right-click on that logger and select Assign to Pipe node, that red marker is going to pop up. So in this next example, you can see that there is GIS data present. If we highlight the correlation, we can see the loggers that are involved. We can see that those loggers are attached to spots on the pipe. So now the next culprit could be that there is a missing pipe junction somewhere, or there is a tiny gap along the pipe. To explain what pipe junctions are, they're an intersection of 3 or more different segments. So for example, this T intersection would be a junction, and this cross intersection up here would also be a junction. So now to check to see if all of our junctions are connected, you're going to want to go up into the top left-hand corner of your map, hover over this word custom, and select pipe junctions. And so now you can see the pipe junctions have appeared in a green or light green balloon with the number 3 or number 4 inside of them. So T intersections are going to appear with the number 3 because there are 3 different segments here, here, and here that are converging. Whereas with the cross intersection, it's going to have a number 4 because there's 1, 2, 3, 4. What we're looking for now is a T intersection or cross intersection that does not have a balloon coming from it, specifically between the 2 loggers that are involved. So if we look closely, we can see that there's this T intersection down here that doesn't look like it has a balloon. And when we zoom in, we can see that there is indeed a gap between this segment and this main right here. Now, just like when we were assigning a logger to a pipe node and we had to create a new pipe node, in this case, we're assigning essentially this pipe node to this pipe. And so we're going to want to create a node close to this one. And when I right click and choose Edit Pipe on this main here, I'm going to click and drag that right next to this node here. Now that has just created the node. So now if I move it a little bit, now we're going to get that pop-up window that's asking us if we want to connect. Choose yes. And so now you can see that that green balloon popped up. We have a pipe junction. That double-headed arrow down here turned into a single-headed arrow. And we had another correlation, our double-headed arrow here, that turned into a red spot. So now in this next example, all the previous culprits have been eliminated. So we know that there is GIS data present. We can see that the loggers here are assigned to a node along the pipe, and we've toggled on the pipe junction to see that there is indeed a junction here, and there wouldn't be a junction here because it's just two segments coming together. So now the next thing to do is to check to see if there are tiny gaps along the main itself. This sometimes happens with GIS data. It's a pretty simple fix if you're just trying to get the location of one correlation sort of as you go. So you want to start right by one of your loggers. You want to right click on that segment of pipe and choose Edit Pipe. So if this were one continuous stretch of pipe, as it should be, this main would be full of nodes. But in this case, as you can see, the nodes stop right here. This is indicating that there is a gap between this node and the node that's on this stretch of pipe. And so just like we did in the pipe junctions step, we're just going to choose this node here and drag it a little ways, and that'll show you that pop-up window asking you if you want to connect the pipe together, and choose yes. So now that stretch of pipe is connected to itself. However, we're still seeing that double-headed arrow, so that means that there must be somewhere another tiny gap. And how we're going to find that is we're just going to go systematically along the length of pipe and look for where those pipe nodes stop. In this case, at this node right here. And we're going to click and drag just a tiny ways, choose yes. Let's zoom out to see what happened. And it looks like we closed all of the tiny gaps in that main, and that gave us that single-headed arrow. A single-headed arrow is a pinpointed correlation. It's just telling you that that sound that those two loggers are hearing is very close to one of the loggers. Last, but certainly not least, is the case that the loggers might be too far apart. The distance between the loggers has exceeded the default correlation limit that was set when your project was created. It's not like you have to check this part last. You can pretty easily tell in most situations that the correlation, if you highlight it, that the correlation is between two loggers that are just simply too far apart. However, this case is a very good example because it's right on the border line. The maximum distance between the loggers that could produce a pinpointed correlation is 1,312.3 feet, or 400 meters. It's simply a recommended limit. Loggers that are further than that distance apart are going to return data that is less accurate. And this is a great example too because it shows you the importance of checking your logger positions. And I go over this in the first mini tutorial that's titled Correcting Logger Positions. But to just demonstrate that quickly here, we're going to do Street View, and we're going to look to see that, okay, this logger is right above this lid, and so now we actually need a node that's closer than this node up here, and I've actually already created a node there. So now when I choose Assign to Pipe node on the logger, I can click on that, and that actually reduced that distance between the loggers by enough that it gave us now a pinpointed red spot. So most of the time, you're not going to be able to just correct logger positions and get them close enough together. Never force it, never change the logger positions to make them close enough, because again, that's not going to give you any usable data. But in this case, making the logger positions more accurate actually gave us a correlation. All right, so let's say that this logger was actually located at this intersection rather than this node, and it did fall outside that correlation limit. There's a way to fix that and set a new default correlation limit. So first, let's check to see how far away these loggers are if we assign this logger back to where it originally was. And to do that, we are actually going to use that same select and extend selection to pipe segment tool that we've used earlier in the tutorial. If we right click, we can see the distance again is 1,315 feet. So now I'm going to show you how to change that default limit so that we can get that correlation spot. Let's go to that Administration tab at the top left, navigate down to Project Settings. It's going to ask you if you want to open the current project view, so click that button and click Project Settings. And at the top, you'll see a list of tabs. Let's navigate over to the correlations tab for now. And if we go down here, we can see the correlation limit is set at 1,312.3 feet. And so we can edit that to be whatever we need it to be. So let's edit it to 1,320 feet. Not a problem if you make this correlation limit, say, 3,000 feet. Just know that if you do get correlations of loggers that are that far apart, they are more likely to be less accurate. It is recommended to not make this correlation limit less than 1,312 feet because that will increase the number of double-headed arrows that you see. So let's click Save. Go back to our leak detection view. Now we're still seeing that double-headed arrow, but sort of refresh this logger here. So we'll click Detach. Go back to Assign and assign it back to this node at the intersection. And now that will have refreshed everything, and now we'll see that red correlation spot. So that's really it for double-headed arrows. That's your checklist you need to go through if you ever see any of them. And at this point, you're kind of seeing how all of these, the previous two mini tutorials and this mini tutorial, they all sort of overlap. They all use the same features. Next up, I might try to do some videos that are related to different products that Gutermann has, as well as wrap up a few loose ends with ZONESCAN Net. So look forward to those, and we'll see you next time.